This morning what I wanted to do, just to kind of recap from yesterday, was your free radical substitution mechanism. Okay, so I think I picked something different to what you did yesterday. Yes, I did, because we picked doing propane yesterday. So I've got ethane. What I want you to do, and you can talk about this, you can ask questions, okay? I want to know that it's gone into your brains though. And if you weren't here yesterday, then you'll be a bit like, oh goodness me, what happened? But we need the 3 steps: initiation, propagation, and termination, okay, for our free radical substitution. The challenge is to see if you can find more than 3 propagation steps. So can you take the substitution a little bit further and go for more than 3 propagation steps and see if you see what would happen, okay? Angie, looks like you might need to do a bit of teaching there, okay? And I'm here to help as well. So let's do that. I'll give you about 7 or 8 minutes to do that. So let's go. Initiation steps, ladies and gents. What have we got? Should be an easy one. Who am I going to pick on first to tell us? Abdullah.
CO2,
So Cl2, we need our UV light, good. And what does that produce again, sorry?
Cl, circle, CO.
Okay, so I'll abbreviate that down, so Cl dot or Cl circle. I'll just do 2 of them rather than plus and plus. Doesn't matter which way round you do it. Propagation steps, the first set of propagation steps in that case. James, one.
Let's say you get a Cl free radical,
Yeah.
and a C2H6.
Yeah.
You'll make a C2H5
C2H5 radical.
and a HCl.
And HCl. Excellent. Okay, one good propagation step. Thank you. Leah.
You get a C2H5 radical,
Yeah.
and then plus CO2.
Yeah.
It would make C2H5Cl
Yeah.
plus the radical.
Perfect. Okay, so the C2H5 radical and chlorine makes a C2H5Cl and a chlorine radical. Fantastic. Ahmed, have you got one to add?
C2H5Cl plus Cl.
C2H5Cl plus a Cl radical
Provide some C2H4Cl radical.
could provide a C2H4Cl and its radical plus HCl. Yeah, that would actually work. Yeah, that's good. That's then kind of taken onto a second substitution of chlorine in. Okay, so actually that probably counts as one of my challenge ones. Okay, there should be another propagation step that's just in with the normal 3, I think.
So I just have a question about this one. What if these worded the parts be C2H5 and then radical Cl4? That would work. Aren't you moving the one that's going to be on the very end of the...
But there would still be hydrogen on the end of the chain as well. Okay, and the end of the chain is either side because it's only too long as well. So it can absolutely work like this, not a problem. Can anyone else just add one more at least propagation step onto there? Janavi. What else have you got?
I don't know if this is right.
But you can certainly try. C2H4Cl radical. Plus C2H5Cl. This could be interesting. Okay. C4H. Was I right there? Yeah.
Right.
Plus a Cl2. Would that work? I'm not sure you'd be able to pull off both of the chlorines in a collision like that. That'd be quite difficult to do. Yeah. Not totally convinced about that one. I'm very sorry. I'm going to rub it out. Jemima. C2H4Cl radical, yeah. plus Cl2. C2H4Cl2, that's perfectly possible. Plus Cl radical, good. Yeah, I like it. And you could actually carry on and keep going if you wanted to. The important ones are definitely here, okay? That's always where you should start with, okay? So, Ziad, what were you going to say?
How do you have 3 CLs to like the last one?
How do you do what, sorry?
The last one, how do you have 3 CLs?
How do I have 3 CLs? Because it's already substituted in 1, like in this equation here.
Isn't it like in the main equation CL2?
The main equation is that, absolutely. But if there's lots of chlorine, lots of UV light, you can keep going. It can keep substituting. It doesn't just happen once. Yeah, the substitution can keep on going. You can get dichloro compounds, you can get trichloro compounds. As long as there's enough chlorine, it can keep reacting, keep substituting out hydrogens all the time. Okay, that's the answer. Termination, Bisma. Terminate.
Cl.
Yeah. Yeah. Okay. So, radical there and there. Okay, so 2 Cl radicals can terminate. Absolutely, yeah. Gabby, one more termination.
C2H5 radical
Yeah.
plus Cl radical is C2H5Cl.
Excellent, okay. There's one other option as well for a nice termination. Leanne?
C2H5 radical plus C2H5 radical, which will give you C4H10.
Exactly, so 2 lots of the C2H5 radical give you C4H10. Okay, that would be the termination product. Fantastic, good. Okay, so hopefully if you weren't here yesterday, you've kind of caught up a little bit with what happens. Yeah? Kumar? Pranesh even? One day I'll say your name right. The wrong bloody button.